Okay, what we do is solving constant acceleration problem. We know the average acceleration is going to be v final minus v initial over time. So we have a velocity time graph. The area under the velocity time graph will be displacement. The area of this shape, trapezoid, is these two sides adding together. Here is v initial plus v final, as you see here, multiplied by the height, which is time, divided by 2. So delta d is equal to 1/2 v final plus v initial multiplied by time. So we want to prove that some other equation we can derive acceleration is v final minus v initial divided by time. You rearrange it for time. So the delta t going to the other side, a going to denominator. Displacement from the previous formula, that area under the graph is given like that. Instead of the time, I put this expression. Then v final plus v initial multiplied by v final minus v initial is equal to v initial power 2 minus v final power 2 minus v initial power 2. How we do it? Because a minus b multiplied by a plus b equal to a power 2 minus b power 2. That's why this multiplication turned it out. So 2 multiplied by a denominator, 2a to the other side is 2a delta t, v final power 2 minus v initial power 2. V initial, we bring it to the other side. So this is what we have. Now we have 4 equations for constant velocity motion, 5 here. The first one, we did talk about that. The second one, delta t is equal to v initial multiplied by t plus half a t2. And here is the area under the graph trapezoid that we did. Here the equation that we drive. And here the last thing, this one and these two are similar, but pay attention. This is v initial multiplied by delta t. Here's v final multiplied by t. When you have v final here, you have minus. When you have v initial here, you have addition. So in each of this equation, we have 4 unknown. If we have 3 of them, knowing 3 of them, knowing the number of these 3, we can solve for 4th one using the proper formula. Let's just do this question. The motorcycle traveled initially. So we have v initial is 12 meters per second west. When it said west, I can make it negative and east, right? And speed, okay. And a speed of 3.45. So we have time, 3.5 seconds. Constant acceleration, a is equal to 5.1. I can make it negative and make this one east, meter second square. Say I have 3 things. What is motorcycle displacement? I need to find delta t. I have 3 things. I need to find 4th one using the proper formula. So going to previous equations, see, I need to find delta d knowing v initial, time, and acceleration. V initial, time, and acceleration. We have this side. I can use this equation to find the displacement. I'm using that equation. In v initial, we put 12, time, we put 3.5, a, you put that, time, you put that. Your answer is west. If you put this negative, your answer will be in east. It's going to be negative 73 in east. Any question?
No, thank you.
Okay, so next question. Now is the velocity reaches from rest. So v initial is 0. It reaches to the velocity. So this is v final. At an altitude of 4.7 above the launch pad, determine the rocket acceleration, which is assumed constant during this motion. So it means in y direction, what is the displacement? Is 4.7, right? So you have a delta d here. You want to find acceleration. Again, you have 3 things. You want to find the 4th one. Using this equation, I have v final, I have v initial, I have delta d. I can rearrange for acceleration. So rearrange it for acceleration, putting the number, and that would be the answer. Any question?
No.
Here is another question. Show that acceleration is opposite in direction to the motion of the rock, and the opposite direction is chosen to be west. So, is that show the acceleration? Okay, sorry, the question is here. A curling rock sliding on going under constant acceleration. So we have acceleration traveling 28 meters west. So this is the displacement. Make sure if you do west, turn it to negative to make it east, because your acceleration is east. From its initial position before to the rest. So V final here is 0. Initial velocity. I want to find V initial. So perhaps you know, if you have a displacement V initial, V final, so V final power 2 is V initial power 2 plus 2a.
Yeah.
Very good. So I have delta D, I have acceleration, I have V final. I can rearrange it for V initial. And the time of travel, again, for the time of travel, I can use delta D equal to V initial multiplied by time plus half AT2. I can do that. Or I can say that V final equal to V initial plus AT. This is easier to do that. So we have we have V initial from previous state, we have V final. You can rearrange it for time, right? So I'm gonna show you the answer here. We use that, we get V initial 1.7 west. And here is the one that I choose. Okay, let me just erase that. Delta time, you range for the delta T, and here the time is 33 seconds. Any question?
No.
So I'm asking you to do question 19, 20, 21, 22, and 24 here.
20, 22.
Yes, an acceleration into 2 dimension. Again, when you want of acceleration, V final minus V initial, you need to do vector addition. Let's say this is your V initial, and here is your V final. How do you add these two vectors? You need to find, because this is V final minus V initial, is the same as V final plus negative V initial. So what you should do, you find the negative of the V initial. And then V final need to be added to the negative V initial. See, I put it successively after each other. So V initial, and from the beginning to the end. So what you do, you have to do the components, right? You find the X and Y components here. You find the X and make sure you find the negative, like make everything negative. You find the X and Y component of that, but make sure you make it negative. And you add them, right, separately. Then the way that we did, put them together using the Pythagorean theorem and using the tan inverse. Okay. This is the question that they have done it using the other way. I want you to do problem 7 using the components. Here is they're using geometry. See if you can find the answer, the same answer, okay? And also for the practice, you do question 25, 26, 27, 28, and 29. These are for practice, okay?
Yes.